Hi everyone, welcome back to ASJ Amazing. Today we are all going to learn a new concept, a topic known as electricity. We are going to learn it in the most simple manner and we all are going to enjoy it together. Okay, the topics that would be covered under this chapter would be atomic structure, what is a charge, what are conductors and what are insulators, what is electric potential and what is potential difference, what is electric current, models of electric current, what is the drift velocity of an electron, what is an electric circuit and how to draw a circuit diagram, what is a resistance and what's the Ohm's law, what does it state, and factors affecting the resistance and how do they affect them. Alright, and what is resistivity, what are ohmic and non-ohmic resistors. To be said in the brief, ohmic are resistors which follow the Ohm's law and non-ohmic which doesn't. After learning the Ohm's law, you will get a clarity about it. And also we are going to know what are superconductors, what are the different combination of resistors that we can connect them into, what is the equivalent resistance of a system of resistors, what is electromotive force and the terminal voltage, heating effect of the current or the Joule's heat law of heating, uses of heating effect of current, electric current, what's an electric power, and how to calculate the cost of the electric energy used in our day-to-day life. Alright, so these all concepts will be covered in the different videos coming after one another, so do watch all the videos. So we'll jump into the first concept of the atomic structure. Alright, so atomic structure makes us to know how an atom looks according to the Near-Bohr model. So there is a dense center known as nucleus which is positively charged with many electrons revolving around them which are negatively charged. So the valence electrons or the electrons in the last shell or the outermost shell are free to move in a conductor made of metals, which constitute the electric current. Thus, the number of free electrons makes the conductor good or bad. Alright, so let's see what's a charge. A charge is a property, intrinsic property of matter by virtue of it can exert an electromagnetic force on its environment or surroundings. The interaction between the charges would be like unlike charges attract, whereas the like charges repel. As you can see in this diagram, which illustrates that the unlike charges like positive and negative charges attract, whereas the like charges like positive and negative repel from each other. Alright, so let's see now what are conductors and insulators. So conductors, as we discussed before, which have more amount of free electrons which allow the electric current to pass through them more freely than the others, whereas insulators which offer more opposition to the electric current, stopping it and not allowing it to go through it, is an insulator. So conductors and insulators are quite contrary. Conductors conduct electricity whereas insulators do not. Alright, so let's see what is an electric potential and electric potential difference. Alright, so what's an electric potential? The electric potential is the work done in bringing one unit positive charge from infinity to that point. So the amount of energy used or the amount of work done on one positive charge or one unit of positive charge from bringing from infinity to that particular point is the electric potential. Now keep in mind what's a potential difference. The potential difference between two specific points in the conductor or circuit is defined as a difference in the electric potential at the two given points. So the difference between two different energy consumed would give us the potential difference. So we have a formula here to find the potential difference or the voltage as we call it. So V equal to W by Q. Here V represents the volts, W represents the joules or the electric potential as we can say, divided by the Q or the charge that we discussed about. Alright, so there is an instrument or the apparatus to measure this potential difference at given any 2 points. That's the voltmeter. we always need to connect the voltmeter in the parallelly to a connection around a component, not directly in the series of the wire. Alright. So let us understand what's the current and solve this question. Alright. So first we'll understand what is a current. So current is represented by a capital I or a small I, which gives coulombs per second or the time. So it's in a cross section in some part of the conductor, the number of charge has been passed to in some specific interval of time. So if I give a conductor, say a metal wire, and take this part, only this part of specific part of the conductor, and if we count the number of charges go through it in 1 second, that would be our current. For example, if 5 coulombs of charge passes through the conductor in 1 second, that means 5 coulomb by 1 second gives us 5 amperes. Yes, amperes is the SI unit of current. Alright. So after knowing about what's an electric current and what is a potential difference over the voltage, we can calculate the above question. Alright, so let us clear all this. Okay. Now, here it is given that the Q is equal to 5 coulombs and the potential difference or the voltage is equal to 15 volts, and we are required to find the work done. Alright, so we can write the formula V equal to W by Q, or the work done per charge. So after transposing the Q to LHS, we get W equal to V times Q. If we substitute the values given from the question, we get 15 volts multiplied with 5 coulombs of charge, giving us 75 joules. Yes, joules is the SI unit of work done, or it is the same SI unit for the energy consumed too. Alright. So the work 75 joules of work is done when a charge of 5 coulombs moving across a conductor having a potential difference equal to 15 volts. Alright, so let us go to the next question. Here, what is the potential difference required? So we need to find what is the potential difference or the voltage. Alright, and what are the other numerical values given to us? 100 joules of work. So the work done is 100 joules. Okay, to carry a charge of 10 coulombs. So okay, so the Q is 10 coulombs. Yes, so we can directly substitute in our formula V equal to W by Q, which is equal to 100 joules by 10 coulomb, giving us 10 volts. So 10 volts of potential difference is required to do 100 joules of work to carry a charge of 10 coulombs between two points. Alright, so let's see the next question. 5000 joules of work. So they already gave it as work done is 5000 joules. Okay, to carry how much charge? So we need to find the Q. Alright, we don't have it. Whereas the potential difference is given as 100 volts. Alright, so V equal to work done per charge, and charge is equal to work done by potential difference. If we substitute the values of 5000 joules by 100 volts, After cancellation we get 50 coulombs of charge, right? So let's see the next topic, drift velocity of electron. So we need to understand this concept little attentively. See, we know electricity before we know what an electron is. So we assume there is a positive charge moving through the conductor making the electric current. So thus we made the current to flow from the positive terminal to negative terminal. But actually in the modern age we know that actually it is done by the electrons which are negatively charged and which move towards the positive terminal from the negative terminal of the power source. So still this convention remains. We have to keep in mind that the direction of the current is opposite to the direction of the electrons move. So what is a drift velocity? Drift velocity is the average velocity or the speed of the electron in a conductor, which is quite less, from 1 mm to 2 mm per second. But we know the current travels nearly to the light speed. So how does this possible? When the electrons are moving so slowly, but still the current flows at a very high speed. So let me explain. Imagine a pipe filled with balls, a single row of balls. If I add a small ball at the one end of the pipe, the other end would give one ball out quite instantaneously. Why is this? How is this possible? As we know, when we add a ball, in case here an electron, it pushes the other one and the other one and the other one, giving out another ball at the other end quite instantaneously. Similarly here an electron pushes another electron. Here pushes means due to the repulsive charges, you can say. And why does one electron start to move the other electron is because due to the potential difference that we give, that is positive and negative potential difference. That is nothing but the drift velocity of an electron. Alright, so let's go to the next topic. So here we are going to learn what is an electric circuit. An electric circuit is a closed path of conducting material where the electric current can pass through or go around. Alright, if it is an open, it's called an open circuit. If it is closed, when the current goes through it, it is known as a closed circuit. So what is a circuit diagram? We represent this electric circuit in a simple terms by using different symbols to make it more understandable. So let us see a few symbols from them. So here you can see an open switch, a closed switch, alright, an open switch, a closed switch, an open switch. Here it makes the circuit open, no current passes through it, whereas in closed switch current passes. And fuse is one of the useful components which is helpful in short circuits. And this is the symbol for battery, showing the connection between two or more cells. And this is the symbol of cells. This is the symbol of voltmeter, as we talked about earlier. And this is the ammeter symbol. Ammeter is also an instrument like a voltmeter, but quite different. It is used for measuring the current in a circuit. Alright, and this should be connected in series, whereas the voltmeter must be connected in parallel. This is the buzzer or the sound component. These two symbols can be used as lamp or bulb. These two symbols can be used as resistors, which have some specific resistance. Sometimes we can use a rheostat or the variable resistor, which can be represented like this. Alright, this rheostat or a variable resistor, without changing complete component, we can change the resistance of it. Alright. Okay. Alright. So now we will understand what is Ohm's law. Okay, Ohm's law states that the brief explanation of Ohm's law is the voltage or the potential difference is directly proportional to the current. Alright, so and the vice versa. So if I increase the voltage, the current increases too. And we can derive the formula of V equal to R into I, where the R stands for the resistance, V stands for the potential difference, and the I stands for the electric current passing through the conductor. We can see the voltage current graph here. As you can see, the voltage increases, the current increases too, and their respective ratio used as a constant or resistance for a particular conductor. This triangle would help us to remember the relation between these three quantities. If you want to find R, you can multiply I and R. If you want to find I, you can divide the V by R. And if you want to find R, you can divide V by I. So, who is the person who contributes this Ohm's law? It's none other than George Simon Ohm, who is a German physicist. Before doing some questions on it, we must remember these three relationships between the voltage, electric current, and the resistance of that particular conductor. So let's dive in and do some questions. So here is the first question. We need to find the resistance if 5 amps of electric current flows through a conductor having a potential difference or the voltage of 15 volts. So R is equal to V by I, which we learned earlier, where V is given as 15 volts and I is given as 5 amps, giving us 3 ohms. Here we have to understand ohms is the SI unit of the resistance. Alright, so let us do the next question. Here potential difference between the terminals of an electric motor is 220 volts. So the overall voltage is 220 volts and the electric current is 5 amps. So I equal to 5, and to it, what would be the resistance of the electric motor? Similar to the previous question, R equal to V by I, which means 220 volts by 5 amps. After the division, we get 44 ohms. So we complete the Ohm's law here and also this part of the video. The next concepts will be continued in the next video. So thank you for watching. We'll continue in the next part. So bye, and do like, share and subscribe, and surely I'm going to release the next video soon, and do watch the continuation of resistance and resistivity. Alright, thank you.